In this fascinating geometry problem, we got this circle, and this sector A has been cut out of it. And the angle of the sector A is alpha, and there's another sector B also cut out of the big circle, and the angle of the sector B is beta. We know that the combined area of sector A and sector B is 165, and that the sum of their perimeters is 82. We do not know the radius of the circle whatsoever, and we need to find the value of alpha plus beta, that is the sum of this angle here and this angle here. If you want to try this on your own, now is the time to pause the video, because I'm starting to solve it right now. First, let's create an equation for the area of the sector A. We'll call it area A, and it equals the area of the circle, which is the total area of this big circle here, times alpha over 360. Now this 360 here represents the entire circle, and alpha is the angle of the sector. So this ratio tells us what fraction of the circle we're dealing with. As for the area of the circle, we can express it as pi times r squared. Pi is given as 22 over 7, but for the time being, it is more convenient to keep it as pi. Next, we'll write an equation for the area of the sector B. We can express it in the same way as the area of sector A. The only difference is that this angle is beta, because that's the angle of sector B. We know the combined area of sector A and sector B is 165, so let's add the two expressions we have written down to see what happens. First, we take area A and bring it down here, and we put a plus sign next to it. And then we take the area B and bring it down here, and their sum equals 165. Pi times r squared is a common factor, so we can write it separately here, and then put everything else into parentheses. These fractions have a common denominator, 360, so we can easily add them. And of course, all this equals 165. Let's keep this piece of information up here. Now, let's create an equation for the perimeter of the sector A. It includes this straight line segment and this straight line segment. They're identical, and they both equal the radius of the circle, so we can write down perimeter A equals 2r. But we need to put a plus here, because the perimeter A also includes this arc, which is part of the circumference of the big circle. So let's write 2 pi r here, and we multiply it by alpha over 360. This alpha is the angle of the sector, and this 360 stands for the entire circle. So their ratio tells us what fraction of the circumference is covered by the arc. Next, we create a similar equation for the perimeter of sector B. And we can simply express it like this, the only difference being this angle beta here, and that's because beta is the angle of the sector B. We know the sum of the two perimeters is 82, so let's add these two together to get this intricate equation. These two r's add up to 4r, and this 2 pi r is a common factor, and we can put the other stuff into the parentheses like this, and it all equals 82. We want to make this as simple as possible, so let's divide everything by 2. This part becomes 2r. These 2's cancel out each other, and we get pi times r here. And this part simply becomes 41. Great! We've got another very cool equation, and we can place it up here. These two equations have a bunch of like terms, so it is obvious that we need to do some sort of elimination or substitution to get to the solution. Now, we'll do something with this one that will make things a lot easier. We'll multiply both sides of it by r. The left-hand side becomes this, and the right-hand side becomes this. And we now have this identical expression in both equations. This entire thing equals 165. So let's just replace this part of the second equation with 165. And now we can take this 41r to the left, where it becomes minus 41r. We've got a quadratic equation, and it factorizes into this. So r is either 11 over 2 or 15. Let's try 11 over 2 and see if it works. In this above equation, we've got an r squared, so we can replace it with 11 over 2 squared. Pi is given as 22 over 7, so let's turn this pi into 22 over 7. I'm factorizing and simplifying stuff, and I don't want to bore you with details, so let's get to the point. When r is 11 over 2, alpha plus beta turns out to be this crazy fraction, which is obviously larger than 360. Now my son has something to say about that. Go ahead, son.
Alpha plus beta can't be wider than 360 degrees. This is nonsense, because an entire circle is 360 degrees. You can't cut sectors from a circle and expect them to add up to something wider than the circle itself. And father, it's not beta, it's beta.
Thank you, son, for making everything clear. 11 over 2 didn't work, so we rule it out and we go for 15. Let's put this finding up here. Here is the equation we came up with earlier in this video. This part is the total area of sector A and sector B, and we know it equals 165, so that's where this 165 comes from. We just found r to be 15, so let's replace this r squared with 15 squared. Pi is given as 22 over 7, so we can also replace this pi with that. I did the math for you, and it turns out alpha plus beta is 84. And let's not forget the degree sign, because alpha and beta are angles. So that's it, people. Alpha plus beta is 84 degrees. I hope you enjoyed the video. You will make me and my son really happy if you push the like button and subscribe to our channel. Have a good day, and see you soon.